Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of x equals 2 to the power of x plus 4. Now, if we have something in the form a to the power of m plus n, this can also be written as a to the power of m times a to the power of n. So what I'm going to do is I'm going to use this property for 2 to the power of x plus 4. Think of 2 as a, x as m, and 4 as n. So this we could rewrite as 2 to the power of x times 2 to the power of 4. So x to the power of x is equal to 2 to the power of x times 2 to the power of 4. Now I'm going to divide both sides by 2 to the power of x. So for our right side here, these two cancel out, and we would just be left with 2 to the power of 4. And for our left side, if we have a to the power of x over b to the power of x, this can also be written as a over b to the power of x. So we have x to the power of x over 2 to the power of x. This can be also written as x over 2 to the power of x. Now what I'm going to do is I'm going to take the power of 1/2 on both sides. Now if we have a to the power of m to the power of n, this is also equal to a to the power of m times n. So 2 to the power of 4 to the power of 1/2, well, what's 4 times 1/2? 2. So this would be 2 to the power of 2. And for our left side here, x times 1/2 is simply just x over 2. So we would have x over 2 to the power of x over 2. Now, if we have something in the form a to the power of a is equal to b to the power of b, then this also means that a is equal to b. So think of x over 2 as a and 2 as b, meaning if we have x over 2 to the power of x over 2 equals 2 to the power of 2, this would also mean that x over 2 is equal to 2. Now, as you can see, we have a simple equation. We simply multiply both sides by 2. These two get canceled out, and we would have x is equal to 2 times 2 is 4. So 4 is our answer. Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 81 to the power of x equals 27 to the power, we have 81 to the power of x minus 27 to the power of x equals 0. Now what I'm first going to do is I'm going to change 81 to 3 to the power of 4. So I'm going to replace 81 with 3 to the power of 4. So now we have 3 to the power of 4 to the power of x minus, now I'm going to change 27 to 3 to the power of 3. So now we have 3 to the power of 3 to the power of x. And this is equal to 0. Now, if we have something in the form a to the power of m to the power of n, this is actually equal to a to the power of m times n. Meaning 3 to the power of 4 to the power of x, well, this would equal 3 to the power of 4 times x, or we could also write that as 4x. Minus, now we're going to do the same thing over here. 3 to the power of 3 to the power of x. This is the same thing as 3 to the power of 3 times x, which is simply just 3x. Now this is equal to 0. Now I'm actually going to add 3 to the power of 3x on both sides. So now we get 3 to the power 4x. These two cancel out. Equals 3 to the power of 3x. Now, because these two bases are the same, this also means that the exponents here are the same as well. Because if we have a to the power of b equals a to the power of c, this means that b is equal to c. Meaning 4x is equal to 3x. So now if I divide by 3 on both sides, I get 4 over 3x is equal to x. Meaning the only value that would fit this would be 0. So x is equal to 0. And as you can see, if we plug 0 in for this equation, we get 81 to the power of 0 minus 27 to the power of 0 equals 0. And anything to the power of 0 is 1. So we get 1 minus 1, which does equal 0.